In this video, you're going to learn how to work with complex numbers in trigonometric form, and this is designed to be like a complete guide. We're going to go through 8 different types of problems together. We're going to talk about writing complex numbers in trigonometric form. We're going to talk about how to multiply complex numbers in trigonometric form, divide complex numbers, use DeMoivre's theorem to bring complex numbers to a power, and then we're also going to learn about how to take the roots of complex numbers. Again, working with complex numbers in trigonometric form is the key here. So let's dive into this video. I've got some formulas here you might want to write down. We're going to be using these as we go through. The first thing we want to do is, remember, a complex number is part real and part imaginary. It's in the what we call A plus BI form, or the standard form of a complex number. Oftentimes they use the letter Z to refer to a complex number, like in this case, Z is equal to 3 plus 4i. And what I want to show you is that you can graph these complex numbers in the complex plane. What does that mean? It means this is like the real number line, and then this over here is like our imaginary direction, okay, our vertical direction. So if we were to plot this, 3 plus 4i, it's like going 3 on the real number line, or to the right, and then 4 in the imaginary direction like that, and we can put a point right there. Now, sometimes you'll see it drawn where they draw a little dashed or dotted line out to that point, and I'll show you why that is in just a minute. When we find what's called the absolute value, okay, of a complex number, what it's giving us is giving us the distance from this origin to this point in the complex plane. So it's kind of like a radius, okay, if you were to think of this as a circle, this is kind of like the radius. And so the way you would find that distance, you can see that this is actually like a right triangle. This is 3, this is 4. And you're just doing the Pythagorean theorem, a squared plus b squared equals c squared. Some students like to use this formula here. It's the square root of the real number squared plus just the b, the coefficient in front of the I squared. So this would be r equals the square root of 3 squared plus 4 squared. Now you don't want to make the mistake and use 4i, because then some students will get like 16i squared, and then they'll say, oh, I squared is -1, and then that's -16, and they're going to be getting something completely different. So just use the coefficient here, the a and the b. So this is 9 plus 16 is 25. The square root of 25 is equal to 5. And so again, if you think of this as a circle, this is like a distance of 5, or a radius of 5 from the origin. Now, when we write a number in trigonometric form, it's written in this form right here, r, and then in parentheses, cosine theta plus I sine theta. Theta is this angle from the positive x-axis counterclockwise, okay, to that radius there. Or the r is actually referred to as the modulus, and the theta here, this angle, is referred to as the argument. But for all practical purposes, you can see it's an angle, and this is like our radius of a circle. So here we've got finding this angle. You can see we have a right triangle. We could just do the tangent inverse of 4 over 3. And so that's where this formula comes from. The angle is the tangent inverse of b over a. So let's write that down. So tan inverse of b, which is 4, over a, which is 3. I'm going to go to the calculator. I'm just going to make sure your calculator's in degrees. I'll just do this one in degrees. You can do it either way, radians or degrees. Sometimes you might know this exact value if it's one that you're familiar with on the unit circle, but in this case, we really don't know the tangent inverse of 4/3. You might, I don't. Okay, so this is 53.13 degrees, and that looks about right. That's about what that angle is. So if I was to write it now in our trigonometric form, I would say our complex number z could be written as 5 cosine 53.13 degrees plus I sine 53.13 degrees. And that's the trigonometric form. So it's good to know how to put it in the trigonometric form, because then we can use some of these other formulas a little bit easier and more effectively. So now let's do another example. If you want to try this one on your own, go ahead and do it. This one's a little bit different, and I recommend you watch this, because sometimes students make a little mistake when they're finding the angle because of the restriction with tangent inverse. Remember, tangent inverse is only restricted from -90 to +90. But what happens in number 2, where our complex number is actually left 5, up 12, we're over here. I'll show you how this works. So this is -5, this is +12. There's our point in the complex plane. Let's go ahead and find the r value, or the absolute value of that complex number. And the way we do that is we just take the square root of a squared plus b squared. We add those together and take the square root. It just, again, comes from the Pythagorean theorem. So 25 plus 144 is 169. The square root of 169 we know is 13, so that's our r value, or like our radius. Now if we want to find the angle, theta, we're going to use the tangent inverse of b over a. So that comes out to the tangent inverse of b, which is 12, over a, which is -5. And let's see, I'm going to go to my calculator. I'm in degrees again. You can follow along, check my work here. I'm getting -67.38 degrees. Now, does this look like -67.38 degrees? No. See, -67.38 degrees is clockwise from the positive x-axis. But you can see our point here is actually in the second quadrant. And notice it's 180 degrees from -67.38. So I'm going to add 180 to write this as a positive angle and to actually represent where that point is actually located, right? So plus 180, I'm getting 100, or you can add pi if you're in radians. I'll just do 180 for here. So this comes out to 112.62 degrees. Okay, so final thing now is to go ahead and write this in the trigonometric form right here. So our complex number would be written like this: r, which is 13, parentheses, cosine of the angle, 112.62 degrees, plus I sine 112.62 degrees. Now, you might be saying, Mario, my teacher does it a little bit different. They write it like this. They say 13 cis 112.62 degrees. Now, the cis is kind of like a short abbreviation. It's like cosine I sine, or you might say my teacher actually puts the I over here, which makes it a little bit more like A plus BI, that form. Or you might even do what they call writing it in polar form, which is you could write it like this. You could say 13 comma 112.62, and they use like these brackets, and that just, again, is another way of writing it. But for this video, let's just work with the trigonometric form. These are all equivalent. Again, you can do it in degrees or radians. Let me erase the whiteboard. Let's talk about the next problem you're going to want to understand. Okay, for number 3 and number 4, we're going to multiply and divide complex numbers in trigonometric form. So if your numbers are not in trigonometric form, you can convert them into trigonometric form, and then we're going to use these two formulas for multiplying and dividing. So for number 3, we want to multiply this complex number z1 times this complex number z2. And when it's in trigonometric form, it's super simple. Basically, all you have to do is multiply the two r values, or the moduli, okay? And so that's going to be 3 times 2, which is equal to 6. And then for the angles, you're just going to add the angles together. So this is going to be pi over 3 plus pi over 6, which pi over 6 is like 30 degrees. Pi over 3 is like 60 degrees. So that's really like 90 degrees, which is pi over 2. So this is going to be cosine pi over 2 plus I sine pi over 2. And that's it. Now you've multiplied them together. Now sometimes your teacher, your book, your worksheet will say, put it back into the standard form of a complex number, this a plus bi form. So the way that you would do that is you would figure out, well, what's cosine of pi over 2? Well, remember on your unit circle, 90 degrees, this is the point 0, comma 1. Cosine's the x-coordinate on the unit circle, so this is going to be 0. And sine of pi over 2 is going to be 1, so this is like 1i here. And so when we distribute, 6 times 0 is 0. 6 times 1i is just going to be 6i. Of course, 0 is nothing, so we could just say this is equal to 6i. And we've put it back into the standard form. This is the trigonometric form. So super easy formula. Just multiply the r values, and then you're going to be adding the angles when you multiply. When you divide, this is also super simple when it's in the trigonometric form. You just have to divide the r values. Now, the order is important, right? So if it's z1 divided by z2, I have to take the r value for the first complex number divided by the r value for the second one. So in this case, it's going to be 3 divided by 2, which is, we'll just leave it as a fraction, 3 over 2. And then what you do is you subtract the angles. Again, the order is important. So if it's z1 divided by z2, I have to take that first angle minus the second angle. You don't want to change the order. So in this case, it would be pi over 3 minus pi over 6. Well, pi over 3, that's like 2 pi over 6 if I multiply the numerator and denominator by 2. 2 pi over 6 minus 1 pi over 6 is 1 pi over 6. So this is going to be cosine 1 pi over 6 plus I sine 1 pi over 6. The beauty of these formulas is, this is always going to be the same. So if you figure it out here, it's going to be the same answer there. Again, we go to our unit circle. Pi over 6 is 30 degrees. At 30 degrees, we know this coordinate here is root 3 over 2 comma 1/2. The cosine is the x-coordinate, so this is going to be square root 3 over 2. The sine is the y-coordinate. This is going to be 1/2. So when I distribute now, this is going to be numerator times numerator. That's going to be 3 square root of 3 over 2 times 2, which is 4, plus 3 times 1 is 3, 2 times 2 is 4. That's 3/4 I. And now it's back in the standard form of a complex number. Sometimes you can just leave it in trigonometric form, but if you want to go back to standard, that would be your result. Let me erase the whiteboard. Let's talk about how you raise a complex number to a power next. Okay, for number 5 now, we're going to be raising a complex number to a power. So we've got this complex number, a plus bi to the 4th power. This is where we use DeMoivre's theorem. And DeMoivre's theorem is this one right here. And what you're going to be doing is you're going to first convert this into the trigonometric form. That makes it easier to then raise it to a power. Now, you might be saying, Mario, couldn't I just take 1 plus square root of 3i times 1 plus square root of 3i times 1 plus square root of 3i times 1 plus square root of 3i, FOIL all that out, combine like terms, simplify, etc. You can do that, and you'll get the correct answer. The only thing is, what happens if this is to the 5th power or the 10th power? Then the math would start to become, very time-consuming. So this is kind of like a shortcut method. The first thing we want to do, though, is convert this to trigonometric form. So we're going to find our r value, okay? And I like to graph this, so we're basically going right 1, up square root of 3. So you're right about there in the complex plane. I'll just draw kind of like a dashed or dotted line. This is 1, this is like square root of 3, okay? So you can see that's like the radius there, but we can use this formula, square root of a squared plus b squared. So that'd be the square root of 1 squared plus square root of 3 squared. That's 1 plus 3 is 4. Square root of 4 is equal to 2. So that makes sense. That's like a radius of a circle with radius 2. Now if I want to find the angle, I do the tangent inverse of b over a. So that's square root of 3 over 1. Now on the unit circle, we do know where tangent is equal to square root of 3. That's going to be at pi over 3 or 60 degrees. Remember right here, this is the point 1/2 comma square root 3 over 2, and we know that tangent is the y over the x. So square root 3 over 2 divided by 1/2 is square root of 3, and so that's this angle right here, so pi over 3. So now let's write our complex number in the trigonometric form. It's going to be our r value 2, cosine of our angle, pi over 3, plus I times sine of our angle, which is also pi over 3, right? These are the same. But what we're doing now is we're raising this complex number to the 4th power, right? So using DeMoivre's theorem, what we do is we take the r value to whatever the power is. So in this case, it's going to be 2 to the 4th power, okay? And we're going to multiply our angle times whatever that power is. So that's going to be cosine of 4 times pi over 3. And same thing over here, sine of 4 times pi over 3, which is 4 pi over 3. Okay, 2 to the 4th we know is 16. 2 times 2 times 2 times 2, 4 times. Cosine of 4 pi over 3. Now remember, our unit circle, 4 pi over 3 is over here. This is the point negative 1/2, negative square root 3 over 2. Cosine is the x-coordinate, so that's going to be negative 1/2. The sine is the y-coordinate, that's going to be negative root 3 over 2. Now I'm going to just distribute and put it back into the standard form, the a plus bi form. So this is going to be 16 times negative 1/2, which is negative 8. This is going to be minus 8 square root of 3i. And you got it. That's what 1 plus square root of 3i to the 4th power is. Let me erase the whiteboard. Let's do another example using DeMoivre's theorem and raising a complex number to a power. You can try this one on your own and we'll go through it together. Okay, what do you think for number 6 here? How would you raise this complex number to the 5th power? Well, if I was going to do it, the first thing I would like to do is kind of plot it. So I'm going right 3 root 2 on the real number line, down 3 root 2 on the imaginary direction here. So that's where our point is located. So this is kind of like 3 root 2. This is kind of like negative 3 root 2. And I want to find the r value. I want to put it into the trigonometric form. So our r value is going to be the square root of a squared plus b squared. So in this case, it's 3 square root of 2 squared plus negative 3 square root of 2 squared. Let's see, this is 9 times 2 is 18. 9 plus 2 is 18. 18 plus 18 is 36. Square root of 36 is 6. Okay, so that's this r value right here. Now to find the angle, I can take the tangent inverse of b over a. So in this case, it's going to be b, which is negative 3 root 2, over a, which is positive 3 root 2. This comes out to negative 1. So we're really figuring out where is tangent equal to negative 1. Now on our unit circle, we know that tangent is negative 1 right here at negative 45 degrees or negative pi over 4. Because this point is root 2 over 2, negative root 2 over 2. So I could do negative pi over 4, or if I go this direction, I could say it's 7 pi over 4. So I'm going to make it a positive angle. I'm going to say 7 pi over 4. So in trigonometric form now, this complex number is actually written like this. It's our r value of 6, cosine of 7 pi over 4, plus I sine 7 pi over 4. Okay, but now we want to raise this to the 5th power. So using DeMoivre's theorem, we take that modulus, that r value, to the 5th power, so 6 to the 5th power, and we're going to multiply our angle, okay, theta times the power, which is 5. So this would come out to 5 times 7 pi over 4, which is 35 pi over 4, plus I sine 35 pi over 4. Now what's 6 to the 5th power? Let's see. I don't know that one off the top of my head. It's 7,776. And okay, we could leave it like this. Now this would be our trigonometric form. So if you wanted to stop there, you could. But let's put it back into the standard form, this a plus bi form, by figuring out what cosine of 35 pi over 4 is. Now 4 goes into 35 8 times with 3 left over. So we're really looking at 8 and 3/4 pi. So 8 pi would be, let's see, it's like 2 pi, 4 pi, 6 pi, 8 pi, 3/4 of pi would be, put us right here. We know the coordinates at this point are going to be negative root 2 over 2, positive root 2 over 2, right? So that means that the cosine is the x coordinate. This would be negative root 2 over 2. This is going to be plus root 2 over 2i. And now if I distribute, that comes out to, let's see, this comes out to 3,888 root 2, and that's negative. And this comes out to plus 3,888 root 2i. And that's your result. So that's when you take this to the 5th power. Again, if you were to write this 5 times and multiply it all out, eventually you would get this. It's just that this is using DeMoivre's theorem, oftentimes a little bit quicker, and you got it. So let me erase the whiteboard. Now let's talk about how to take the nth roots of a complex number, like the square roots, the cube roots, the fourth roots, etc. Okay, for number 7 now, we're going to find the cube roots of negative 4 root 3 minus 4i. So how do we do that? Well, first thing I like to do, like you've seen, is I like to kind of graph it just to see where it is in the complex plane. We're going left 4 root 3 and down 4. So that puts you somewhere right about there. So this is like negative 4 root 3. This is like negative 4. And then this would be like your r value, kind of like your radius. So let's go ahead and solve for that r value by taking the square root of a squared, which is negative 4 square root of 3 squared, plus b squared, that's negative 4 squared. So let's see, negative 4 squared is 16, square root of 3 squared is 3, 16 times 3 is 48, negative 4 squared is 16, that's square root of 64, which is equal to 8. So that's our r value. And our angle now, we're going to use the tangent inverse of b over a. So that comes out to tangent inverse of b, which is negative 4, over a, which is negative 4 square root of 3, which these two negatives cancel. This reduces down to the tangent inverse of 1 over square root of 3, or you can rationalize it to root 3 over 3. So this is one that we know on our unit circle. Where does tangent equal root 3 over 3? Well, that's going to be right over here. No, it's not. It's going to be right over here at a 30-degree angle. That's a pi over 6. This is coordinate is root 3 over 2 comma 1/2, and we know tangent is y over x, and 1/2 over root 3 over 2 would simplify then to root 3 over 3. But notice that our point here in the complex plane is over here in the third quadrant, okay, which means we're going to have to add pi. This angle is actually going to be not pi over 6, but 7 pi over 6. So again, you know, tangent inverse, it's always going to give you an angle on that restricted domain from negative pi over 2 to positive pi over 2. That's why it helps to graph it or plot it. So our angle here is 7 pi over 6. Okay, so we've got our R value, we've got our angle. Now we're going to write our complex number in trigonometric form. So that's going to be 8 cosine 7 pi over 6 plus I sine 7 pi over 6. Okay, now when you take the cube roots of a complex number, you get 3 roots. If you take the 4th root, you get 4 answers, 5th root, 5 answers, etc. And we can use this formula here, this nth roots formula. It's very complicated, but there's a little easier way to approach it, okay? And I'll see if I can explain this. This is how teachers oftentimes will explain it or show you. What you're going to do is you're going to take the nth root of the modulus, or the R value. So in this case, since we're finding the cube roots, I'm going to take the cube root of 8, which is 2. So this is going to be 2. And then you see how this says theta divided by n? So I'm going to take the angle, I'm going to divide it by n, which is the root. In this case, we're taking the cube root of this whole thing, okay? Or you can think of it as the 1/3 power. So what I'm going to do is I'm going to take theta, 7 pi over 6, divided by 3, which comes out to 7 pi over 18. So this is cosine 7 pi over 18 plus I sine 7 pi over 18. Now, then to find the next angle, or the next one, it's going to be the same R value, but what you're going to do is you're going to take 2 pi, or 360 if you're in degrees, divided by 3 since we're taking the cube root. So we're going to be adding 2 pi over 3 to get to the next angle. Now, 2 pi over 3 is the same as 12 pi over 18. So I'm going to add 12 pi over 18 to this angle. I'll tell you a little bit more about why this works in regards to the formula in just a moment. And then to find the next one, we're going to add another 2 pi over 3, which is the same as adding 12 pi over 18, which is going to give us 31 pi over 18. Okay, and then these are our 3 cube roots of our complex number in trigonometric form. Now, if you want to put it back into the standard form, the a plus bi form, this part you'll have to do on your calculator most likely, because these angles you probably don't know from the unit circle, and then you're going to distribute the 2 and you're going to put it into the a plus bi form. But what's interesting about these roots of a complex number is that they're equally spaced around a circle. So for example, if we had a circle with radius 2, 7 pi over 18 is a little bit less than pi over 2. It would put you right about over here, okay? I'll just draw a dotted line. 19 pi over 18 is a little bit past pi, so that would be somewhere right about here. And 31 pi over 18 is somewhere maybe right about like over here roughly. But what's interesting, see how they're equally spaced around this circle, and they're 2 pi divided by 3 apart, okay? They're like 120 degrees apart. And so that's kind of an interesting result of these roots of complex numbers. But going back to the formula here, see what you would do if you use this formula is if you're finding the cube root, the k value would be 0, 1, and 2. So if when you're finding the 3 answers, first you put k equals 0. Of course, 0 times anything is just going to be 0. And so that's why I was just taking the angle divided by 3. So I started off with 7 pi over 6 divided by 3 to get that first angle. To get the next one, you'd say k equals 1. Okay, and so what I'm doing is I'm taking, see, theta divided by 3 plus 2 pi times 1, which is 2 pi divided by 3. So that's why I added 2 pi over 3. Then when k is equal to 2, that becomes 4 pi over 3, but that's like adding 2 pi over 3 twice. So that's why I added 2 pi over 3 and 2 pi over 3 again. So long story short, You're going to take the nth root of whatever the r value is. You're going to divide this angle by whatever that, if it's a cube root 3, fourth root 4, that gives you your first angle. And then if you take 2 pi divided by whatever the root is, if it's a cube root, you divide by 3. If it's a fourth root, you divide by 4. And that's what you're going to be adding each time to get the next angle, next angle, next angle. Let's do another example. I'll erase the whiteboard, see if you can do this next one on your own, and we'll go over it together. Okay, while you're doing this last problem, finding the fourth roots of negative 81i, I just wanted to let you know if you want to join the channel as a channel member, you can get access to over 125 videos on there now. But the one you'll be interested in is I've got some pre-calculus and midterm and final exam reviews on there. So if you're preparing for the midterm or final exam, you might want to check that out. There's some good videos on there for you. But let's see if we can do this problem now. What I like to do here, this one is kind of an interesting one because this is like 0 minus 81i. So I'm going 0 on the real number line, down 81 on the imaginary direction. So I'm right there, right on that axis. So that means that this, again, if you think this is a circle, this is like a radius of 81. So I really didn't even have to use the formula so much. You can, but you can see that that radius is just going to be 81. Now the angle also is pretty easy to identify. You can see that this is like 3 pi over 2 or 270 degrees. So that's pretty simple, but again, you can use the formula. I like to plot it first. But in trigonometric form now, our complex number would look like this. It's 81 cosine 3 pi over 2 plus I sine 3 pi over 2. But what we're doing is we're finding the fourth roots of this number, which is kind of like taking it to the 1/4 power, right? That's the same as the fourth root. Using our nth roots formula or the pattern I was showing you earlier, we take the fourth root of 81, which is 3. We divide the angle by 4 since we're taking the fourth root, so that's going to be 3 pi over 8. That's going to be our first angle, plus I sine 3 pi over 8. To get the next angle, we take 2 pi, or if you're in degrees, 360, divided by 4. Remember, when you take these roots, they're going to be equally spaced around a circle of radius 3, and 2 pi divided by 4 is pi over 2. So now pi over 2 is the same thing as 4 pi over 8. So I'm going to add 4 pi over 8 to get the next angle, which gives us 7 pi over 8. To get the next angle, I'm adding another pi over 2, which is like adding another 4 pi over 8, which is going to give us 11 pi over 8. And then one more, because remember you get 4 answers if you have the fourth root of a complex number. And so that's going to be adding another 4 pi over 8, which is 15 pi over 8. Now, if you were to graph these, again, they're going to be equally spaced. If you were to plot all of them, they're going to be equally spaced at 90 degrees apart, or pi over 2 apart. And again, if you want to go back into the complex form, you're going to have to use your calculator probably on this. You can then distribute and put it into this a plus bi form for each of the 4 roots. So great job if you're able to follow this complete guide to complex numbers. If you want more practice, I'll put another video that I did right there if you want to learn more about complex numbers. And I'll see you in my other pre-calculus videos. I'll talk to you soon.